Hi guys, so today we're looking at the circle theorem, and our learning intention for today is to be able to apply the circle theorem knowledge to a variety of questions. Today we're looking at more complex questions. Okay, before we start, let's just remind ourselves of our 4 circle theorems that we need to know. So theorem 1, angles subtended from the same arc are equal. Theorem 2, angles at the centre are double the angle at the outside when subtended from the same arc. Opposite sides of a cyclic quadrilateral add up to 180 degrees. And an angle subtended from a diameter is a right angle, 90 degrees. Okay, so when we're doing these questions, you must look back at these theorems and see which one of them you can use to solve for the unknown angle. In the following questions, we're going to be looking at exam past paper questions on the circle theorem, where we have to use these following theorems to solve for an unknown angle. Let's have a look at exam questions on the circle theorem. So let's talk through one of them. So in question 1, which is the 2020 paper, we're told that we have a circle as shown. We're told that the angle P or T, so remember your angle, it's just P or T, so that's the angle at the middle letter is equal to 55 degrees, and we're told that SQ and QT are the same length, and that's shown by those 2 little lines here as well. So they're the same length. We are asked to find the angle. So let's just look at what angle we're asked to find. Okay, so T, so we're going from T to Q to S. So we can see that we're looking for the angle in here. So this is our angle TQS. Okay, so what can we tell about this diagram? Well, we can tell that this angle, the angle we're looking for, that's the angle TQS, is standing on the same arc. So let me just color in that arc. So it's standing on that same arc as the angle P or T. So we know that these 2 angles are standing on the same arc. And our circle theorem states that angles on the same arc are equal, and therefore the angle of P or T will be equal to the angle TQS. If the angle P or T is 55 degrees, it means that the angle TQS must also be 55 degrees. So let's look at part B. We're asked to find the angle TPOR. So again, let's just draw where this angle is. So we're going from T to P to OR. So we're looking for this angle here. So I'm just going to call it angle P. Okay, so I'm looking for angle P. All right, so how can I find angle P? Well, let's look at the theorem we used in part A. In part A, we stated that angles on the same arc are equal. So we know that this angle P is standing on the same arc as our angle T, P, or our angle P is standing on the same arc as angle S, angle TSQ. So if I can find angle S, I will also find angle P. How can we find angle S? Well, we know Let's just draw it out here again. So here's S. This is 55. This is T. We know that in this triangle, TSQ, we have an isosceles triangle because two sides are equal. So our triangle TSQ is an isosceles, as we're told that two sides are equal. When we have two equal sides, we know that their opposite sides will also be equal. So we know that the angle T and the angle S will be equal to each other. So the opposite sides, angle T and angle S, will be equal to each other. How can we find angle T and angle S? We know that in a triangle, all angles add up to 180 degrees. So how can we find our unknown angles? We take our known angle of 55 degrees from 180, which gives us 125. And then we divide this value by 2 because our remaining angles are equal, which means that our angle of TSQ and our angle STQ are both equal to 62.5 degrees. Okay, so going back to our diagram, we know that this angle is 62.5 and we know that this angle is 62.5. Now remember what the question is asking you to find. We're trying to find the angle TPR. So we're finding this angle up here. Well, as we already stated, TPR is on the same arc as TSQ. Therefore, our angle TPR is equal to 62.5 degrees.